So now let's talk about how we determine the sample size. Okay. Now remember that the general formula to compute confidence intervals is x bar plus minus z sub alpha over 2 times sigma x divided by the square root of n. Okay. And if you recall, the second term here is what is known as the margin of error. Okay. So here's a question that we want to ask. The question we want to ask is, what is the sample size that we need to achieve a given margin of error? Okay. So how do we do this? First, let's let E be the desired margin of error. Okay. And our goal is to be able to solve for the sample size n, right? Okay. So in order to do this, all we have to do is to set E be equal to the margin of error. So you set E be equal to Z sub alpha over 2 times sigma x divided by the square root of n. Okay. So if you solve this equation for n is going to be equal to Z sub alpha over 2 times sigma x divided by E all square. Okay. So now in order to solve for the sample size n here, we need to know three things, right? We need to know E, which is the desired margin of error. We need to know Z sub alpha over 2. And then we need to know sigma x. Okay? So now let's talk about each of these items in detail. Right? E is a desired margin of error. Typically, that's something that we're given, right? Given to us. Z sub alpha over 2 is a quantity that depends on the confidence level. Okay, so for example, if you're talking about 90% confidence interval, right, then alpha is equal to 1 minus 0.9, which is 0.1, and so alpha over 2 is 0.05, and then Z sub alpha over 2 is 1.645, right? We walked through this, okay? We've seen this before, okay? Now the last thing here is the population standard deviation. But this is something that we also talked about, right? You don't usually have access to the population. So how do you know what this is? Okay. So there are two ways for people to estimate this quantity in practice, right? So two ways to come up with estimates. The first way is to conduct a pilot study. Okay. So essentially, the idea is we conduct the survey or the experiment on a small sample, and then use it as the as an estimate for the population standard deviation. Okay. Now, the second way people do to come up with an estimate for sigma x is to use a comparable study. Okay, so for example, if you want to find, the mean household income for students at West Georgia, maybe you look at a school similar to West Georgia, and look at the standard deviation of students at that school, right? Of household incomes of students at that school. So either way, regardless of what you do, the goal is to come up with a reliable estimate. Okay. So now let's look at an example. Okay. Suppose that rents are normally distributed with a standard deviation of $280, right? Okay. We want to know what's the sample size we need. So that the 95% confidence interval has a margin of error of $50. Okay. Again, let's go ahead and specify what we know, right? So we know that here we assume that we know the population standard deviation here of 280, but again, there are two ways to come up with this number, right? You look at a comparable study or you do a pilot. Okay, so either way, sigma x here is 280. Okay, we're looking at the 95% confidence interval, so alpha is 1 minus 0.95, which is 0.05. So alpha over 2 is 0.025, and z sub alpha over 2 is 1.96. Okay, I'm not going to go over how to find this number again. You can go back and look at the notes or look at the a previous video. Okay, and here we're looking at the a margin of error of 50. Okay, so now all we need to do is to apply the formula, right? We know that n must be equal to z sub alpha over 2 So it's z sub alpha over 2 times sigma x divided by e all square, right? Okay, so this is equivalent to z sub alpha over 2 all square times sigma x all square divided by e square. Okay, so this is 1.96 square times 280 square divided by 50 square. Okay, so if you do the math here, you're gonna get 120.47. Okay, so the answer to the original question is you need a sample size of 120.47 in order for the 95% confidence interval to have a margin of error of 50. Okay, now you should be thinking this is super weird, right? Because we're talking about a sample size. How can a sample size be a decimal? Okay, so the rule when we determine sample size is always round up if the answer is a decimal number. Okay, so in this case, we round up to 121. Okay, so this is the sample size we need.